Another game that sort of shows the difference between being purely selfish versus thinking about inequality, thinking about fairness is the ultimatum game. And so this is another way, this is a different type of game because our previous games were called simultaneous games, right? And so simultaneous games means that the players choose their strategies at the same time and they don't know what the other person is choosing, right? So when we were choosing between IPC and Terminator, when we did the game talking about pesticides, Bala didn't know what Anil was choosing, and Anil didn't know what Bala was choosing. This is a sequential game. And so in a sequential game, one player moves, player two sees what player one has done, and then player two moves. So in this game, we have a proposer and a responder. And we actually usually set this up so that the proposer can propose any amount, but we'll just look at two different offers here. So the ultimatum game starts when the proposer is given an amount of money, usually, in a lab, it's usually like $10 or $20, and told that they can split it any way they want between themselves and the responder, with the caveat that the responder then either gets to accept that split, in which case the proposer gets the proposal and the responder gets what the proposer responded, or reject it, in which case they both get zero. So let's look at this one example. So the proposer can offer either a 50-50 split, so they each get, $5, say, or an 80-20 split, in which the proposer gets 80 and the responder gets 20%, right? So like $8 and $2. So, and then the responder gets to decide. And so the way we solve these sequential games is by going backwards. And so we want to look at player two's payoffs. So if player two is over here, right, where the offer has been 50-50, then player two is choosing either between 50 or 0. And so 50 is larger than 0, and so we can underline that. Uh, and that's what they would choose if they ended up there. On the other hand, if they're over here where the offer was 80 and 20, they're choosing between 20 and 0. Well, still, 20 is greater than 0, and so we would expect uh, player 2 to accept, right, if they're just purely self-interested. Now, player 1 looks at that. Player says, okay, well, if I do a 50-50 split, I'll end up getting 50%, right? So maybe $5. If I do an 80-20 split, then I'll get $8. 8 is bigger than 5, and so I'm going to do this one, right? And so this is our Nash equilibrium. And in fact, our Nash equilibrium is such that the proposer will give the minimum amount to the responder and expect that the responder will accept it because any positive amount is greater than 0. But that's not usually what happens, right? Usually what happens is that any offer that's 20% or less is rejected. And the reason we think that is because the responder cares about fairness, cares about inequality, and so is unwilling to accept an unequal split of the money. And so if we look at some data, what we can see, so here we have data, the blue data is from Emory students, so college students from the United States, and the red data is from farmers in Kenya. And if it's a dark shade, that means the offer was rejected, and if it's a light shade, that means the offer was accepted. And this is 0%, 10%, 20%, 30%, 40%, 50%. So you can see, first of all, the students were more selfish. They were more likely to offer 0%, but any 0% was rejected by both the farmers and the students. 10%, about 2/3 of the students accepted it who were offered, whereas all of the farmers rejected it. 20%, again, about 2/3 of the students accepted it. Almost all of the farmers rejected it. At 30%, now we see more of the farmers accepting it, a little over 50%, it looks like. But we see most of the offers being in this 30 to 40% range. 30% for the students and 40% for the farmers. And the farmers were then willing to accept it. And of course, a 50-50 split was always accepted. And so the offers here are taking into account, right, those social preferences, because the proposers clearly knew that if they didn't offer a fair amount, then the responder was likely to reject it. And so that's an interesting example where people clearly know that there are some social preferences, some inequality aversion, whether we're talking about college students in the United States or farmers in Kenya. Interestingly, we can set this game up so that we're more likely to end up with a smaller split for the responder and for the responder to be more likely to accept it. And the way we do that is by having multiple responders. And so the idea with multiple responders is that if either responder accepts it, so if I accept it and you don't, then I get to keep what it was and you don't. Whereas if we both accept it, then we split it. And what we see is that once there's competition that's introduced in between the responders, then the responders are much less likely to reject these smaller shares, right? So with one responder, 0% is always rejected, 5% is always rejected, even 10, 15, 20% are rejected 80% of the time. But with two responders, only 75% reject zero, and, we're going down 55 or 60% for 5 and 10, less than 50% for 15, and about 30% for a 20% split. And so, one example that we can think about, that this might be a good model for is when there's an employer who is offering a wage to workers. If there's only one worker available, that worker has a lot of bargaining power, right? And we're going to talk about that more in the next chapters. And the worker can say, no, I'm not going to do that. You have to give me a better offer. But if there are two workers available for one job, now the employer has a lot more bargaining power, right? So now the employer can say, no, it's $5 an hour, take it or leave it. And one of those workers is more likely to take it, especially if the alternative is to have no job at all. So one of the problems that we're sort of identifying here with these social interactions is a problem of coordination. And so when we were talking about, Bala and Anil choosing between rice and cassava, we saw that, depending on how the payoffs were open or turned out, we could end up with two Nash equilibria, in which case we might end up in the bad or suboptimal equilibria with no way to get to the socially optimal equilibrium. And so oftentimes if we can come up with some way to coordinate and some way to make sure that people follow that coordination, we can move from the suboptimal outcome to the optimal one. So one example that we can think of that is obviously very relevant today is climate change, right? And so we can have each country, right? So one of the problems, obviously, with climate change is that we have lots and lots of countries involved, with lots and lots of players within those countries. And they're trying to choose between conducting business as usual um, and restricting emissions, right? Carbon emissions. And if we can all restrict, then we could get to the best outcome, but not restricting is better for the players. And so we can end up in this bad outcome where nobody restricts. We just continue business as usual. We continue emitting carbon, and we end up with significant climate change and really bad problems. So, inequality aversion, reciprocity, we could move to, the social optimum, which is restrict, restrict. But, we might need something more, right? And so these multi-lateral agreements like the Paris Accords, like the Kyoto Protocols, are designed to try to get us from moving to the bad outcome of business as usual to the best outcome of restrictions. But it's not actually that simple because there are so many different players involved, so many different, sort of political forces in each country that getting everybody to agree can end up with being very difficult. So if we think about this chapter, right, we thought about social interactions that can be modeled as games. And games basically just mean that there's more than one player. and that those players choose their best response. And we said that a Nash equilibrium is really just a mutual best response. Social dilemmas can be resolved by, binding agreements. That's really the way it's done mostly in modern market economies, or peer punishment or social preferences. Those tend to happen more in smaller groups. And we can often, we should be able to solve the problem of multiple Nash equilibria and the coordination problems involved by making more binding agreements. But of course, the problem in something like climate change is, international agreements are very difficult, and there's lots and lots of players involved.